So this last video is about doing the glasses pre-assessment. I'm going to skip one. All of you should have a formula sheet for being able to calculate volumes. This is all about volume. However, if you don't, you can go online and Google it. All volumes, just with a simple Google search, the volume of a cylinder, if you turn that up on a Google, it'll come up on a Google search very quickly. Same thing with the volume of, and you notice they say here, this has a cylindrical top, but a hemispherical bottom. And this right here is the cone, right? So I'm skipping one because everyone in the class was able to, with the volume of a cylinder, pi r squared times h, right, get this correct. But we started to have trouble on glass 2 and glass 3 when you're trying to decompose the figures. And decomposing the figures here means two things. One, you're trying to figure out what the two shapes that you can calculate the volumes for, because we don't have a volume for this strange composite shape, but we do know how to find the volume of a cylinder, right? Pi r squared h. And we also know how to find the volume of a sphere. The volume of a sphere, and you can look this up online, is 4/3 pi r to the third. And so if we're taking a volume of a hemisphere, like half of that, we would just need to use this formula and then divide by 2. So then the main part becomes identifying the important parts, so decomposing it into the important parts. For example, this cylinder has a radius of 3 and a height of 3, right? A radius of 3 centimeters and a height of 3 centimeters. So from there we can use the pi r squared h formula to figure out that part of the volume. And then for the bottom part, this hemisphere has a radius of 3 centimeters. And you can think about that because really this is, radius just means from the center to the edge. So that's going to be another 3 centimeters to get as far down. And since it says it's a hemisphere, we can assume that the radius goes from here to here as well. So from here, then that would just be 4/3 pi times 3 to the third. And if I multiply that out, 3 to the third is 27, but then divide by 3 is 9, times 4 is 36 pi, but then we remember we need to cut that in half. So that's going to be the same thing as 18 pi cubic centimeters, right? And I'm going to leave it in terms of pi so that I can just work with whole numbers. You can multiply that out if you'd rather see a more practical number.